right, hi everybody. I'm going to start with chapter 3, section 1, on the atom. This is for my honors chemistry class. We're going to talk a little bit about some of the ways that atoms have been described, and then we're going to talk a little bit further later on in the chapter about some of the math we can do with atoms, and we're going to focus a little bit on what information that really gives us. So in order to get there, one of the things we want to review is just that when something happens, so when a substance is transformed from one thing into another, it is typically referred to as a chemical reaction. The law of conservation of mass then kind of goes a little further and says that we cannot create or destroy mass from nothing in ordinary chemical reactions and physical changes. So the amount of stuff that we started with, whether that be number of atoms or specific compounds, say you started with 100 grams of water, at the end of a reaction we still have to have that 100 grams of water. It may be in a couple different forms. It may have escaped the container that we're working in, but the law of conservation of mass says that it cannot just disappear into thin air. It has to be accounted for. So from that, we can talk about the other two laws that are in this chapter. The first one is the law of definite proportions, which says that a chemical compound is always going to have the same elements in exactly the same proportions by mass, regardless of the size of the sample or source of the compound. What this means is carbon dioxide will always be carbon dioxide. So CO2 will always be written CO2, no matter what chemical equation it might be in. From there, we can then also talk about the last one, which is the law of multiple proportions, which just says that if you have a compound or two that are composed of the same two elements, the ratio of the masses of the second element combined with a certain mass of the first element is always a ratio of small whole numbers. In other words, this is why we don't see things like CO 2.5. It's why our whole numbers are always accounted for in our molecular formulas that we do our chemical reactions with. From there, we can just kind of look at a couple of different examples. The first is the law of conservation of mass. It says that if we started with H2 and we had 1/2 of O2, so one oxygen atom, we have to still have one oxygen and two hydrogen atoms at the end. Same thing with the sulfur and the oxygen molecule, which when we add them together, we still have to have a sulfur and two oxygens, just like we did on the left side of the equation, and so on and so forth. Okay, that's the law of conservation of mass. The law of multiple proportions says that if we have something like nitrogen monoxide, it will always be nitrogen monoxide. In other words, the ratio of the masses of the two will always be the same number. Same thing with any other type of compound. Basically what we're saying is NO2 will always be NO2, and the ratio of the masses of N to O are always going to be the same no matter what. From there, we can talk about some of the very, very first descriptions of atoms, and that's a man by the name of John Dalton who came up with that information. Dalton's atomic theory has 5 parts. And a lot of these are still ones that very basically describe atoms today, and at least one of them is no longer correct because it has been debunked by looking even closer at atoms in terms of their subatomic particles. So the first one says that all matter is composed of extremely small particles that we call atoms. Cool, we all agree with that. That is absolutely correct. You can't make anything smaller than an atom. Atoms of a given element are going to be identical in size, mass, and other properties. So for instance, all oxygen atoms are going to be the same in terms of their size, how much they weigh, how they react with other atoms, and so on and so forth. Different elements do not have the same size, mass, and other properties. So an atom of oxygen is not the same as an atom of nitrogen. Seems pretty sensible, but do know that this is before we had the highly technical equipment that we currently have at our disposal. Number 3 is the one that I was telling you about is not entirely correct any longer. Atoms cannot be subdivided, created, or destroyed. Now, no, atoms cannot be created or destroyed. They are typically already in existence. But atoms can be combined to create new atoms, and that's a nuclear chemistry idea. Another thing that can happen is atoms can in fact be subdivided. We have subatomic particles now, so we know neutrons, protons, and electrons are all the subatomic particles that make up our different atoms. So number 3 hasn't aged well. Number 4 says that atoms of different elements can combine in simple whole number ratios to form chemical compounds. This goes along with the law of multiple proportions. Whole number ratios, atoms of several different elements can, of course, combine. We know that we can make compounds from different elements. And number 5, what it says is that chemical reactions, atoms can be combined, separated, and rearranged, but they don't just disappear. So we're not going to change an atom of oxygen into 2 atoms of carbon. That's not something we're going to do. But we may start with 2 atoms of oxygen, and then on the right side, have those 2 atoms of oxygen be part of, say, carbon dioxide. Have we changed the atoms? No. Have we combined them into a new arrangement? Yes, and that's perfectly okay. All right, from there we can talk about how there are, of course, some what we would call inconsistencies with Dalton's atomic theory. Modern atomic theory is more, in terms of modern, I would say from the 1960s on. Not all aspects of his theory actually are correct. I mean, we've already gone through and we've said atoms are going to be divisible. We know we can look at everything even smaller. And the other thing that we've debunked is that a given element can have different atoms, or can have atoms of different masses. We call these isotopes, and we'll learn a little bit more about those in our next section. Some important concepts are, of course, going to stay the same, that all matter is going to generally be composed of atoms, and that one element's atoms has different properties than another element's atoms. And that brings us to section 2. So I'm going to go ahead and I'm going to stop this video, and I'm going to upload this one separately from section 2. All right, see you in a bit.